everybody, this is Miss Bufford, and in this video we're going to talk about organization of the periodic table of elements. And your learning goals are to be able to identify the location of metals, nonmetals, and metalloids on the periodic table, differentiate between groups and periods, and to be able to distinguish between transition elements and main group elements. So our first slide here is all about metals, nonmetals, and metalloids. And if you take a look at our picture, we've got the metals represented by all the light blue boxes. Then we've got our nonmetals represented by the green boxes, and our metalloids represented by the few orange boxes right there on our stair step. We call this a stair step here on the periodic table. All right. If you'll notice that metals are the most abundant element or type of element that there is. So most elements that exist are metallic. Metals tend to be malleable, so they can be hammered or shaped without breaking. They tend to be ductile, so they have the ability to be stretched into a wire. They have a metallic luster. They generally tend to be good conductors of heat and electricity. And one of the most important things I would like for you guys to remember is that they tend to lose electrons to form cations, right? So we're going to talk more about this in our next unit when we talk about chemical bonding. But it's really important to start remembering that metals tend to lose their valence electrons and they form positively charged ions. Remember, a cation is a positively charged ion. All right, and then the next group that we're going to talk about is the nonmetals, and that's represented again by all the green boxes here on the periodic table. So you can see that there are a lot fewer of the nonmetals. These tend to be brittle when they're solid. They tend to have more of a dull appearance, so they're not really shiny. They're poor conductors of heat and electricity, which means that they're really good at insulating, so keeping things from flowing. And one important thing that I really would like for you guys to remember is that they tend to gain electrons and form anions, or negatively charged ions. So if they're pulling in those negative charges, they're going to have a negative charge overall. All right. And then let's talk about the metalloids. The metalloids are on this little stair step right here. And metalloids, they're in between the metals and the nonmetals. And so they share properties of both metals and nonmetals. For example, they can be good conductors of heat and electricity under certain conditions, and they can appear lustrous and metallic, but they can be brittle at the same time. So in general, their physical properties tend to be more metallic in nature, but their chemical properties tend to be more non-metallic in nature, right? And so now let's talk about the difference between periods and groups on the periodic table. So we've already kind of talked about what periods are when we talked about electron configuration in our last unit, but a period is just that horizontal grouping of elements on the periodic table, so the rows that go across. And then a group is a vertical group or vertical grouping of elements on the periodic table. All right, so groups on the periodic table have some things in common, and they have their chemical properties in common. Which means that they react similarly with other substances because they all have the same number of valence electrons in their outer shell. So all of the elements in a group have the same valence electron configurations. All right, even though they've got more energy levels, their outer electrons have the same configuration. And so remember that valence electrons are the ones that determine the chemical properties of an element. And periods on the periodic table. So elements within a period on the periodic table have the same number of energy levels. So we talked about how these numbers right here when we did electron configurations tell you how many energy levels the atoms in that period have. And so what they have in common is just the number of energy levels. All right, and then now let's talk about main group elements versus transition elements. So we've got our main group elements. Those are all shaded in this dark gray color right here and right here. These are the most abundant elements in the universe, and because of that, we call them the representative elements, right? These are very reactive and very chemically predictable. Because their valence electrons are all in their outer energy level, so it's easy for us to predict what kind of chemistry that they're going to undergo. The transition elements, on the other hand, with this yellow box right here in the D block, these are less abundant than the main group elements, and they're less reactive and less chemically predictable than main group elements because their valence electrons are found in more than one shell. Because of this, they tend to hold on to them better. So these D block elements will have some d orbital valence electrons. Because those electrons are deeper in another energy level, then they tend to hold on to them better and be less reactive. All right, and then the inner transition elements, which are the two groups down here at the bottom, we call these the rare earth elements, not because they're rare, but because they're very chemically reactive and they're difficult to separate or refine out of the compounds that they're found in naturally in nature. And this group up here, this top group, which we'll talk more about in the next video, actually contains elements that can be found in nature, and there's a lot of synthetically produced elements in this group right here. But we'll talk about those a little bit more in detail in the next video. But that's it for this video. I hope you guys, I hope this was helpful. If you have any questions, let me know. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.